right, so today, continuing on with the nature of code, we're this time I'm doing one of the examples. So not one of the challenges, the exercises. The example is 1.10, or which is a ball that accelerates towards the mouse. What's interesting about this one is that I'm gonna need normalize and I'm gonna need normalize. And normalize is where we take the vector and we, normalize it, as it would say, down to a number between 0 and 1. Which, of course, I have not done yet. Hi, Chantilly, welcome to the stream. So, I will explain a little bit more as we get closer to that, but let's see. Actually, I wanted to call that move exercise 110 to example 1. Okay, so the other thing that I want to do is I want to start creating some GIFs. Basically, the idea here is that as I build these things out, I want to be able to save them away. Because one thing I've noticed is I've been rewriting a whole bunch of code over and over and over again. And it would be really awesome if I had some modules for that. And I also realized that my microphone cable is right touching my mouse. So I'm going to mute that. And unmute. Okay. Hopefully I didn't hit the cable and cause some weird noises coming over the line, but everything should be good now. Also, let me know, how is the sound volume? I played around with it a little tiny bit, made the music volume slightly louder. So let me know how that is. So the first thing, I know that I'm going to need the pvector class.lua. I keep on forgetting to update Studio Code in between. Awesome, sound is good, great. The big thing about these Lua classes is that they're kind of similar to how JavaScript classes were back in ECMAScript 5 days. So I could do something like local vector, empty table, vector, let's see. I keep on using like a single character for this. I think I want to continue that. Maybe I'm just going to use C for class. Or T for table. I could do that. So T.x equals x. I said x. t dot y equals y. Return t. So what I want to do is take this code, because this is the base for a new class. Let's create a guest for this. This would be maybe a this determine what language it is? Sometimes it can. Sometimes... Oh, that's wrong. I'm wondering if there's a way for me to tell it, like, hey, use this, but I don't see one. Oh well. That'd be really cool if I could say, hey, this is Lua. Maybe it recognizes it, maybe it doesn't. Okay, so, things that I'm going to need here. We're going to have a class circle as well. Which is kind of going to look like that. Circle is going to take a location and a radius. Not sure if it needs anything else. Okay, so you can say location. Radius. So the idea here is that we could say vector acquire vector class dot. And I'm going to say is local circle acquire okay, so function love dot load. So in here we're going to say our location. You can just say local location equals vector dot new. Let's also do our good old width and height. So say width equals graphics get height. And this can be width divided by 2, height divided by 2. Okay, so put it right in the center. And we can say circle equals circle.new location and 10. So in love.draw, we'll just say, hey, circle, draw yourself. And we'll just say we only have one of them, so how about set the color first, so graphics set color. Okay, so set it to white, and then we're just going to say love.graphics.circle mode fill. The X is going to be self.location.x, self.location.y. Radius is self.radius. Okay, so got that in there, and then that should draw it. Syntax error, circle class 9 equals expected dash. Circle class 9. Yes, that should be an equals. Okay, cool. We got our circle right in the middle. Exactly what we wanted. So, because we have our p vector, time to look at the example. What I can do is we can find this online, because this entire Nature codebook is online. This is all, okay, so this is what I'm going to make. And this is basically our update function. So what I have to do is I have to figure out what's the rest of it. What am I supposed to do? But the interesting thing is that I'm going to have to normalize. And so far, I have not actually had to implement normalize in any of my code, because I had found that the pvector class that's given to me in processing has the normalize error, and it works just fine. Here, of course, we don't have vectors, so I have to add normalization myself. Okay, so when I update the circle, and here's the general steps. I'm going to pause this. Calculate a vector that points from the object to the target location. Normalize that vector, reducing its length to 1. Scale that vector to an appropriate value, and assign that vector to an acceleration. So first we have to find out where the mouse is. So we can do that in main. Okay, so what I really want to do is say mouse location equals get location. Okay, so in here we can do this. We can say, which means, of course, I need to know how to get the mouse. This is obviously how to do it in processing, but that's not necessarily how I can do that in Love 2D. So there's love.mouse, get cursor, returns the current X position of the mouse, returns the current Y position. So is that a function? It is a function. Nice. Okay, so I can just do love.mouse.get X. So local X equals love.mouse.get X. Equals love.mouse.get y. We can say return p vector new x and y. So now I have new mouse location vector, which solves this first part right here. Now dir equals sub. Oh, I need to get the direction. And the way we're going to do that is we're going to subtract the mouse and the location. Right, so the current location of the circle and the current location of the mouse. So I subtract those and put that into a new vector. I can get the direction between the circle and the mouse. I don't think I need, I think local is fine for this. And I think, I'm betting local is going to be good with this too. So, direction equals get. So what they're doing right here is they're using essentially a static. And I wonder if I can do static, basically do something like this. P vector dot sub, and then pass it in two things. So we'd say mouse location and circle dot location. But what this means is that we're going to have to, in the pvector class here, have a static function attached here. And that sounds to me, I think I should be able to do this. Function pvector dot sub. And this is going to take vector 1, vector 2. Now the way we do, I mean, I think the subtract math is pretty much going to be pretty simple, where we're just going to say we want to return a new vector. So I wonder if I can do that just simply here, where I can say return pvector dot new v1 dot x minus v2 dot x v1 dot y minus v2 dot y. So theoretically, that will return a new vector which will go into direction. I should be able to verify this with a nice print. -400. Oh, and as I move around, I'm getting this distance, and it is going nice. Really far away. I'm guessing this is in pixels because as far away as I can get is 400. I believe this is 800 across. So that is perfect. It's working exactly the way I want it to. So the next thing to do would be to normalize. And we're going to normalize the direction. So we want to say direction dot normalize. But here's the thing. I'm not sure how to normalize yet. I need to go look that up, which is somewhere up above here. So that's fine. Normalize. Okay, normalizing vectors. Calculating the magnitude of a vector is only beginning. The magnitude function up to So it looks like to create the normalization function, we first need to create the magnitude function. And luckily that's what we wanted right before. Okay, so let's create the magnitude. Understanding how to calculate the length, also known as the magnitude of a vector, is incredibly useful and important. Notice in the above, okay, so the length is the hypotenuse, so that would be the magnitude. I guess that makes sense. The magnitude, how long between two different points, two different vectors. And that's a nice example of, okay. So magnitude just returns square root of x squared and y squared. Makes sense. So in pvector class, I'm going to need methods. And these will be, well, I guess all the normal methods won't, I won't need that. So function pvector mag. We're going to be returning the square root of x squared plus y squared. Let's find out how to do square root. I guess this isn't going to be a love thing. This is going to be a Lua thing. So let's do Lua. Square root near the bottom. Return the square root of a given number. Only non-negative arguments are allowed. So just math that square root. Cool, okay. So I can just do that. So return math dot square root, And here's where it's going to be, so x squared it's plus time, it's plus because it's x squared plus y squared equals z squared, where a squared plus b squared equals c squared. I remember my algebra, kind of, sort of. Alright, so we're going to do self.x. Is there a power? I don't need e. I'm not seeing any like pow or power, so the closest one is the x, but that returns e raised to the power my val. I don't really want that though. Okay, we'll just do this. Times self.x plus self.y times self.y. So that should do that. That should give you the magnitude. Okay, so then we're going to normalize. So that means we have to do function p vector normalize. And here, so what we're saying here is we grab the magnitude and then we divide by magnitude. Well, now we have to see how vector is worth with dividing. Scale the vector with division. Okay. Where is multiplication? To scale a vector, we multiply each component by a scalar. So we get x equals x times n and divide will be the same thing. So we also need division. And this is going to be a number. So we're just going to see self.x equals self.x divided by num. Self.y equals self.y divided by num. Okay, we got our magnitude. So normally what we would say is, okay, get the magnitude and then divide by that magnitude. Then that should make sure we go down to a number between 0 and 1. But as this does make sense, if we have a magnitude of vector 0, dividing by 0 is kind of a bad thing. So interesting. So we just don't do anything because if the magnitude is 0, then I guess we're already 0. So let's do this. So normalize. So we first want to get the magnitude. So local magnitude equals self once I have that, I can now say if the I am trying to remember how if not. Is it bang or is it just not? Literally the word not. Okay, cool. So if not, magnitude equals 0, then what are we going to do? We're going to say what was that? That was, oh, just divide by magnitude. So self div by magnitude. Otherwise, don't do anything at all. Okay, so we can normalize now. That was so far up there. Okay. Acceleration. Right, here we go. So we normalized. Then we want to scale by 0.5. So I believe that's scaling it down. Which means, of course, okay, so what this, so after we normalize, we need to scale it up. So direction dot, and so these should not be dots.
What's the smell?
That one's a dot because it's a static. These ones are not static, so this is kind of just molt, and we're going to hand it 0.5, which means in this class, right next, right before division, let's say, molt. So this is going to be pretty much the same thing as the division, except instead of dividing, I multiply. So let's do self.x equals self.x times self.y equals self.y times So that should scale it. I think it's scaling it down just a little bit, but I could be wrong. It could be scaling it way up. I always get this math backwards and have to try it. And acceleration equals dir. And then we can say we'll have a velocity add acceleration, velocity limit top speed, location add velocity. So the circle should keep track of its own velocity as well, shouldn't it? Because then we'll do location add velocity. So if I do local velocity, or this would be interesting. So when a circle begins, it just automatically has a velocity of nothing. let's, okay. I was trying to get cute there. Let's just do this here. Velocity, velocity. It's that way. This way, I can now say local velocity equals p vector new. We'll give it nothing at all. So 0 and 0. So here, I'll hand it velocity. So now that I have this, it's inside of the circle. Velocity add acceleration. So now I can say circle dot velocity add and acceleration equals direction. Oh, well, okay, so that's just letting me know that the direction is the acceleration, isn't it? So it's really just this direction. We're just adding this direction to it. And then we can just say circle, let's see, dot velocity limit top speed. Now this is going to be interesting because I could say top speed equals, I'm going to say 25 right now. I don't know what this number should be. But what's interesting here is that I'm going to have this limit on as well, which is going to drop x and y of that velocity vector, which means I need to add add and limit in here. So let's put add in. And it's going to be a vector. So we're just going to say self.x equals self.x plus v.x, x self.y equals self.y plus v.y. So there's that. We also have this limit. I'm not sure where to put it, so I'll put it down here. Function p vector limit top speed. So we can now say this is really just going to be a num. So self.x, or rather, if self.x is greater than num, then self.x equals to num. And if self.y is greater than num, y is equal to num. All right, cool. So now that's moving to the right, let's say. If it's moving to the left, that means it has a negative, which is fine. Okay, so it has negative, which means that I need to set, so if .y is greater than num, set that way, but I also need to check, hey, can I do this as an else if? Can I say else if self.x is less than, I think it's num times -1, because I don't think I can do negative num. here at least. Then self.x equals num times -1. Alright, so I can do the same thing here. Else if self.y is less than num times -1, then self.y equals num times -1. Okay, so that should limit both in the positive and negative ranges. And then I want to location add velocity. So update, we're just going to say circle dot location add circle dot velocity. So this has been a lot of code. Let's see if it is working. Yes, it does. It's a little bit fast for me. Top speed, 25 is way, way, way too fast. Let's go 10. That's pretty cool. Let's go even slightly slower, 5. Hey, it chases around my mouse. So one funny thing is because it's going at maximum speed, there's no slowdown. So when it hits the spot where my mouse is, it just constantly circles around because it's trying to get there. Also, it has trouble moving in straight lines. Like a laser cat. Yeah. It's chasing me. It definitely likes to move at these diagonals a little bit more. Like straight left and straight right, it doesn't want to do. I think that's because it's trying to move X and Y, and they're never exactly on the right amount, so it's always bouncing up and down a little bit. I wonder if I can tweak that with the magnitude here. So can I change this to, like if I do 0.1, what does that do? It's bigger. That's actually pretty cool. I like this one a lot. So what if I do like a full 2? That's just starting to go crazy. Okay, so what if I say 0.01, like really tiny? Oh, now it's orbiting. I like this one a lot. I like this one a lot because I can it feels like I can play with it a little bit, but I can affect it a lot more. Partially because it's going a lot this slow, but partially because its orbit is now really long. And so that's what the magnitude is doing, is it's changing how close to where it wants to be is. Because if I set it really high, like 50, it's constantly jumping back and forth. But it's now able to look a little bit closer, like it's able to handle X and Y's. I bet there would be a tweak number that I can find that would be perfect, so it doesn't look like it's going crazy. But this is really cool. I like it. I'm going to change this back to 0.1. 0.5. I think that's fine. Maybe like 0.1. Yeah, okay. This one's, I like this one a lot. So let us oh, and so this is interesting. So love is reporting that my mouse is at the very edge of the screen, even though it left. It's just keeping that there. That's pretty cool. So what I want to do is I want to say, I want to create a whole bunch of these. And also, let's update our pvector class that we have in the GIST. Cool, so I can just use this next time. I've got a full vector with all of these methods on it. If I ever need to add more of them, I'll just add them here. So if I want to first create a circle that has random colors. So t dot red equals love dot random 0 2 5. And so to set color will be, actually, can I do this? All right, self dot red. You will be green. You will be blue. Get a random color there. Okay, cool. So now what I want to do is I want to create a nice array of these. So let's do, we have our top speed. We can also have different speeds. We can play with this. So we can say circles equals an empty table. And we can, I'm wondering if it would be really interesting if I started creating, just like create a whole bunch of them, but put them off the edge of the screen at a random location. So we can now say, do a for loop. So for I equals 1, and let's say like 10, do end. What we want to do is move these up. So you can say, so gonna be hard. I can put that into the circle. So I can say local top speed equals 5. So location velocity. And then this is going to be circles. Oh, table dot insert circles. Pass that in. And we're also going to want it so we give it radius. So I can also say radius equals love dot math dot random between 1 and 10, 15. Top speed is going to be between love dot math dot random between, let's say, 1 and, I had 5, let's do 10. So you get some really slow and really fast. And then what we want to do is we want to say, okay, so table.insert, we have the radius, and we can now pass in top speed. So our circle can also take top speed, t dot top speed equals top speed. So in here, we're going to do for I and circle in I pair circles do and this will just be C. And we can do the same thing here. So for I, and then circle pair. I'm going to try just a full circle because that way I don't need to rename these. Circles do. Tab these all in. And theoretically, that should be all I need to do. Let's find out. Do I create a whole bunch of circles in the center and have them all chase? No. Attempt to call global iPair. Main 27. For I, a nil value. Oh, iPairs. I thought last time I did iPair and it was wrong, but I think it's this time it was wrong. Attempt to compare nil with number. P-vector class line 42. Limit, right, okay, so in limit here, I pass top speed into the circle, which means that limit doesn't, I just tell the circle to limit velocity. So I can just say circle limit velocity. Oh wait, no, I got it. Circle velocity limit circle dot top speed, and I think that's with a capital S. Yes. And there you go, 10 balls, each with different speeds, all coming around. Oh, that's cool. It would also be interesting to have a different multitude come in here. I might play with that a little bit later, but I want to see also now if I can get it to appear at random positions, left and right, and up and down. So our location, the velocity I'm happy with. The location I want to be either way left or way right. So let's try this. Location. Hey Backlog, welcome to the stream. You made it? Did you make one of these? Let's say, get off screen location. Function. Oh, okay. Emotional intelligence thing. Oh, that's the, you had mentioned you were going to go to a meetup group about emotional intelligence and how to get people to buy stuff from you. Made it here before it was over. Yes. Well, I'm glad you did. You can see the fruits of my labor, which so far is up. It's unfortunately I broke it right now because what I want to do is I want to get a location that's random off the screen. So first of all, if I can create a random number. So local r equals love.math.random and have it be between 0 or 1 and 4. So the theory is that if it's 1, I want it to be somewhere on the top. So if r equals 1, then I'm going to say, I can also here do my local x, y. Okay, so if r equals 1, I want y is going to be equal to negative. Let's just do, I know that my radius can't be more than 15, which means diameter is 30. Let's do like 50. Let's just say, oops, that's not what I meant to do. That means a 50 above will always be more. Okay, so y equals negative 50, x equals love.compress random between 0 and width. Else if r equals 2, then. So in 2, I was thinking it could be the right hand side. So x is now going to equal width plus 50. Y is going to equal love.math.random between 0 and height. Else if r equals 3, then. So this is the bottom, so it's pretty much going to be the opposite of this one right here. We're just going to say y equals height plus 50, and that is fine. And finally, else x equals negative 50, and then y equals this one. Okay, cannot forget. I want to return a new tvector.new x and y. Hey Danny, welcome to the stream. Steph says hi. Well, I say hi back. Hi Steph. You're on the last exercise in chapter 1. So this isn't the exercise, this is the example. So I do still need to do that. I don't know if I'm going to do that on stream or not, but I am doing this example right here, accelerating towards the mouse. But I do want to sort of play with this, implement the above example with a variable magnitude of acceleration, stronger when it's closer or farther away. I think that would be interesting to do as well. Let's see if this causes them to be created somewhere randomly. It looks like it did. Let's do that again. I wonder. Well, yeah, so they're all coming from off screen. Some of them are really slow, some of them are really fast. That's pretty cool. And then what I was thinking is I could create one. If I just do one right here. My keyboard stopped working.
Oh, I'm plug it back in.
Ah, there we go. Okay, so if I just do a single one. I know, this has been happening in the last couple days, and it's a little bit annoying, and I don't know exactly what is going on with that. And it's not something that it's a little bit scary, because I may have to buy a new keyboard. Okay, so what I want to do is in update, I'm thinking I could create a new circle. So I can now say, in fact, I don't even need this to be 4. That would be silly. I could take all this and throw it into a function. So just add circle. Throw this stuff in here. Back one. And I'm now thinking, what if, for right now, I want to keep you as just stable. Let's do 5. Location, get off screen location, that's fine. Velocity, it starts as nothing. Radius. Let's have you be, everything can just be a radius of 5. But every time that we update, I also want to say, this is just add circle. And I have my add circle there. So theoretically, I should now be getting tons of circles. And they're just constantly being added in. Of course, they're never going away, so I'm kind of just creating infinite circles, but they're all appearing out of nowhere. They're all coming in here. There's this really interesting, I can't really move my mouse because it moves all this stuff. As I move this, they all sort of try to come together. But I can't really point my finger also because that doesn't work. But along that that x-axis and the y-axis, it kind of looks like a double helix, everything coming together. So let's play with some of these limits here. So I have my Molt. I want to go back to that 0, 1. And so now it still becomes this circle. It's actually interesting. It's becoming a square. And everything is sort of, so its acceleration is always the same no matter how far away it is, so that's why they always move together like that, and it looks like it just freezes. And of course there's no collision. So it would be interesting if I made these smaller. Radius 2. Feels like they're the same size, doesn't it? That's because I never changed these. Radius. I know, it's weird that they're creating a square around there. So this is pretty cool. It's still creating that square, but I think it's because every single one has the same speed that it's coming in at. And it hits the location of the cursor, but then keeps on going because it has that current speed, and it has to turn around. And the way it does it just happens to form this cube. It should create a circle, except it's not. I just realized my collar has been totally messed up this entire time. Okay, so I think the last thing that would be interesting is make a bunch of them die after a certain amount of time. So maybe give them a lifespan. So if I say t dot max life equals so how would I know what the max life is? It would be something like because I'm calling D constantly, and the draw, so the new location X, that's also gonna be interesting. I wonder if I can tie that to the actual, because right now I'm moving as fast as I possibly can. I'm not using the delta time. So if I'm saying, what was it before? I think it was velocity add direction. I think it's molt dt times 30. That should slow it down. Nope. vector class 15 is that molt. Oh, it's add. Oh, right, okay. So, hold on. Undo that. Undo that. I probably want to first do... So can I just do this right here? Can I say molt dt times 30? Should create a circle or eat each other and grow in radius. That would be cool if I set that up. So this is a lot smaller. It's still creating that square, which is interesting. They're definitely moving faster now. I wonder if I want something like 15. I also wonder if I want to use add. Right, because add takes this thing. What did I... It must be volt. Because add direction, I am also multiplying it by dt 15. I could also just say dt, pass the dt, and we'll say just seeing how I can it just feels weird when I do that, like I'm manipulating space-time. They do pause now when I go, so that's a good sign. Okay, so what I want to do is I want to decide like how many ticks this thing survives. And after X amount, it dies. So I can say T dot lifespan equals and this is unfortunately this is not based upon the delta time, which sucks. So I either have to guess or I have to figure out some other way of doing it. Like if I have a tick where every time I draw I increase it, but again, draw is based upon an unknown number. So if I say something like 100, they should die really quickly. So then in love.update, if circle should die, then what I would want to do is remove this circle. So how do I remove something? Can I just set it to nil? Can I just say circles of I equals to nil? Then what I could do is say, okay, you died. You're no longer displayed at all. Should die. So it's just going to return a Boolean, true or false. So what we want to do is we want to see lifespan. We also want to see how many ticks this thing has been alive, how many seconds. Wasn't there something in Love? It's starting to tax my computer. Or at least it turned the fans on. Was there a way for me to get time? Get average delta, returns the average delta time over the last seconds. Turns to current frames per second. Turns amount of time since some time in the past. That is not helpful. And I want to pause. So, number time, the time in seconds. Is this like time since the epoch? Resulting time difference in seconds. And they're literally just saying start and get time. So I guess that's time since the epoch. Or some other time that should be hopefully reliable. So if I say t dot birth time equals love dot timer dot get time. Lifespan equals how many, let's just say like 30 seconds. That's how long it can live. Maybe even less than that. Maybe I can just say my birth time is 11:59 p.m. Let's say it lasts for like 15 seconds. So then in should die with a capital D, we can say if or maybe I can just say local delta time equals, and the new one, so love dot timer dot get time, timer dot get time minus self dot birth time if dt is greater than lifespan, then return true, and else return false. End. I think I did that correctly. Let's find out. No, I did not. Attempt to compare nil with number. And should die 30. So that's because it's self. So the theory I have is they're supposed to die really quickly, but maybe 15 seconds is way too long. I feel like they're getting there really quickly. So maybe if I say something like 5 seconds, we'd be able to see a bigger difference. Or it just kills them all. That wasn't good. So, circle should die, then circles of I equals nil, and then that causes a problem here, doesn't it? Is there a, in Lua, is there a remove? So, Lua table remove. So table dot remove okay, A1 to move from that end. A pop operation is equivalent to this. To insert the other end of the structure, we use table.insert to remove from that end. So this should allow us to do that. So I think what I really want to do is say table dot remove circles I. it seems like 5 seconds is even too long for this. 2 seconds. Yeah, okay, so the circle is... So that square is definitely not becoming too big this time. So, wow. 2 seconds. That's what I need to set here. So that's how long these circles exist, and then they're just constantly being created from random positions all around from the outside, and then they're coming in. And then what would make it interesting is if I start putting some of these randoms back in, where top speed is love dot math dot random between 1 and 10, and radius is love dot math dot random between 1 and 15. So those small circles are definitely not surviving very long, and the big ones are. So I think the real answer would be slow it down so decelerate it as it approaches the mouse cursor. When it arrives, then I can remove it. When it's first coming in, make it like speed really fast up. I think the way the direction is calculated causes this square. They should be going towards your mouse, but instead they're going towards the nearest axis of your mouse. I think that's probably correct. What I'm getting the direction is so subtract the mouse location with the circle location. That causes the line straight up and down and straight left and right also. Alright, but that'll have to be for another time because it's been about an hour and a half and I'm going to call it for the night. But this has been a lot of fun to create this thing. I can see a lot of interesting uses for this, like creating a space game with gravity forces where planets are rotating each other or things like that. That'd be a lot of fun. Or little waves or any other type of thing. I think there's a lot of stuff that I can do with this. Anyways, make it move to music and you have a cool viz. That is true. If I could load the music and read the music in Love, then I could do some really amazing things. Yeah, it also kind of looks like a vortex, doesn't it? If I could also measure when it gets to the center and when it actually has arrived, so like the difference is really, 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 really small, then I can just delete it at that time. But yeah, that is pretty cool. I am going to go and switch to my thanks for watching screen. So again, thank you guys for stopping by and watching the stream. It was a lot of fun to make. I plan on streaming again on Wednesday night, and if I haven't already on my own built the acceleration part of this, then that's what we're going to be doing. Anyways, thanks again for coming, and I'll see you guys next time.